Welcome guys, I'm Dr. Avitech, and in this video, we're going to be solving this very problem. So before we get started, remember to hit the subscribe button, like this video, and share it across to your classmates. So the first thing we want to do is, the function is periodic. It's periodic, so this is the first question on Fourier series. So it's periodic. The first thing we want to do is to, first of all, describe this function. Let's see if we can. Now, as you can see, if you notice, the period of this function has to be 2 pi. Now, why would it be 2 pi? Because I have 0 is where I see a line going upwards. I notice that at 2 pi, same line went upwards again. And the next 2 pi, because 2 pi plus 2 pi is 4 pi. So the next 2 pi again, the line is going upwards. You kind of notice that, oh, this line is just going straight above, straight above, straight above, like all the same direction. So it means if this is OA, what is from O to A is similar again from what is from here to B, and also similar from what will be from here to C if it continues. So I notice that, oh, all of these lines are actually just the same. So it's periodic. So, and this line is all the way from 0 to 2 pi, all the way from 0 to 2 pi. So let's consider 0 to 2 pi, because the period is 2 pi, and we're noticing that the only line between 0 and 2 pi is just this line OA, just the line OA. So let us find the equation for the line OA. First thing is, at this very point, 0, we know that this will be 0, 0. That's a point. So we know that's going to be 0, 0. And the next one is, we know that this is 2 pi, so x is 2 pi. So this is 2 pi, then y is pi, because the A is at pi, and for x is at 2 pi. So now let us find the equation. Now remember, to find the equation of a line, we're going to say y minus y1 over x minus x1 equal y2 minus y1 over x2 minus x1. So that's, what's it called? Line. So this is y. Now, y1 and x1, these are both zeros, because this is the origin, right? So these are both zeros, because s is 0, y is 0. So these two are both zeros. So we're only going to be having y minus 0 over x minus 0. So this is just y minus over x. That's going to just be y over x, because the minus 0 will just go away. Equal to, now what is y2? Let's come back here. You know, if this is x1, y1, this will be s2, y2. So s2 is 2 pi, y2 is pi. So y2 here, we have pi over x2 is 2 pi. Now pi can cancel out pi. So this means we have y over x equal 1 over 2. Because when pi and this pi cancel, there will be a 1 at the top remaining. So that's 1 over 2. Now what are we trying to find here? We're trying to make y the subject, because we're trying to say y is equal to something, something. So what we have to do is to multiply both sides by x. Because if we multiply both sides by x, we're then going to have y standing alone. So multiply both sides by x equal 1 over 2 times x. So this s will cancel out this x. Y will then become half of x. And this, ladies and gentlemen, is my function. So I'm going to say f of x is equal half x. And this is 0 less than x less than 2 pi. So that's just it. We've been able to find this. So take notes, please, take notes. When you're giving your equation in Fourier series, you can either be given a graph, then you have to describe that graph analytically, or you'll be given the function directly. If you're given the function directly, you can just move straight ahead. You can just move straight ahead to finding your coefficients. But if you're not given this directly, you would have to find it from the graph that you are given. And that is why there's a video on analytic description of a periodic function. So this is what we have. Now remember, in Fourier series, there are 3 coefficients that we must find. We must find a naught, we must find a sub n, and we must find b sub n. So there's a naught, there's a sub n, there's b sub n. So a naught, I normally like saying that a naught is just the area of the shape we have. A naught is just the area of that. It's like the area of it. So here's the thing. A naught is 1 over pi integral from minus pi to pi of f of x dx. Now this is the formula for a naught. But remember that our x value is from 0 to 2 pi, right? So this would then become 1 over pi integral from 0 to 2 pi of f of x dx. Now take note that the formula involving pi for Fourier series, which looks like the most common, is only used when the period is 2 pi. Let me say that again. There are formulas in Fourier series that you will always have 1 over pi, minus pi to pi. When you see a formula like this in Fourier series, that means the period is what? 2 pi. If the period is not 2 pi, then we use the much more general formula that has L. So I believe I've already explained that when I was deriving the formula for Fourier series. So I'm using this formula because the period is what? 2 pi. So let's continue. Now, this integral you see here, this box you see here, because we're all here to learn, this box we see here is basically the area of the shape of this very function. It's basically the area of the shape of this very function. So you can either solve this if you wish, you can either solve that, or you could just do what I want to do. So here's what I want to do. I'm just going to say this is 1 over pi times area of this triangle, because this is a triangle, area of that triangle. And what is the formula for area of a triangle? It's half base times height. So this is 1 over pi times half times, what is the base? At the bottom, what is the base? The base is 2 pi, because this is 0 to 2 pi. So 0 to 2 pi, that will be 2 pi times, what is the height? How high is it? It's just pi, because this is 0 to pi. So let's do this. 2 we cancel out 2, pi we cancel out pi, so we have pi remaining. So that is a naught. But let me solve this. So we see that it's still the same if we use the integration. So a naught is 1 over pi integral from 0 to 2 pi of f of x dx. So this is 1 over pi integral from 0 to 2 pi. Now what is f of x? F of x is half of x, right? So this is half x dx. Now this is 1 over pi. The half is a constant. So I can kind of bring it outside. So let us say times half integral from 0 to 2 pi of x dx. Beautiful. Okay, so this is 1 times 1 is 1. Pi times 2 is 2 pi. Okay, now if you should integrate x, you would have s squared over 2. Remember that to integrate x, we're going to say this is x, 1 plus 1 over 1 plus 1. So this would then be s squared over 2 if we integrate. Okay, and then our limit is from 0 to 2 pi. Beautiful. Now this is 1 over 2 pi times, this over 2 is also a constant. The over 2 here is also a constant, so I can bring it out again. You know, this is 1, so 1 over 2 is a constant. So this is 1 over 2, and then only the s squared would be having the 0 to 2 pi. Remember that this is with respect to x, right? That's why I was able to bring out the over 2, because 2 is a constant here. Yeah, it's very tiny. Okay, so this is 1 over 4 pi, and then times, let us put in 2 pi here. So this will be 2 pi squared minus 0 squared when you put in your limits. So the first x will be 2 pi, x will be 0 later on. So we're going to have 2 pi all squared minus 0 squared. So this is 1 over 4 pi times 2 pi squared is 4 pi squared, because 2 squared is 4, pi squared is pi squared. The minus 0, that's just throw that away. So 4 we cancel out 4, pi squared over pi is pi. So you can see that it's still the same answer. It's still the same answer. So sometimes, if I can find the area of the shape I have, I basically, the integral part of a naught, I will just put in the value. If I can find the area. So don't get it wrong, if you can find the area. So with more examples, I'm going to show you how to just easily solve this using this. If you're not sure of it, please use the integral. So a sub n is 1 over pi integral from 0 to 2 pi of f of s cos nx dx. Now remember, what does a sub n do for us? Fourier series is all about writing functions. It's all about writing functions in terms of sines and cosine. Now, in this very function, if you are finding a naught, you are trying to see how much this function can be modeled as a cosine function. So we're trying to see if cosine is contained, if the information of this graph has cosine embedded inside of it. So let's see. And how we know is to multiply that function by cosine and then we integrate. So let's see. So this would be, for this very one, unless you draw this out, you actually have to just find the integral. So this is 1 over pi, integral from 0 to 2 pi, f of x is half of x, and then cosine of nx dx. Now remember that the half is a constant, right? So bring out the half. So this will be 1 over 2 pi, because 1 times 1 is 1, pi times 2 is 2 pi. And then integral from 0 to 2 pi of x cos nx dx. Okay, so this is 1 over 2 pi. Then what do we do next? This will be integration by parts. This will be integration by parts. But the thing is, I can't exactly, start writing the integral by parts formula. So here's a shortcut. Here's something I normally do. So this is x, right? So I'm going to write x down. And I'm going to start differentiating x until I get 0. So this is x, then I'm going to differentiate x, I'll get 1. Differentiate 1, I'm going to get 0. But 0 is not useful, so I'm not going to write it. So that's it. Next thing I'm going to do. This is cosine of nx. I'm going to integrate it. So integrate cos. Remember, you're going to have sine. So this is sine nx. And then you divide by what? N. You divide by n. Because you must differentiate the angle, remember. In trigonometric integration, you integrate the cosine, differentiate the angle nx, and then you divide by that very result. Okay, and then times this very value you see here, sine nx over n, integrate it again. Remember, I'm following a procedure here. This is normally called the I method. It's normally called the I method. What I'm just doing is called the I method. Differentiate, integrate. So the first one I did when I wrote x was to differentiate x until I get 0. Then the cosine of nx, I will start integrating it until the last part. So integrate sine of nx. First of all, sine will give us minus cosine. So this is minus cos nx. Then if you should differentiate the angle nx, you will get n. But remember, there's been an n in the expression before. So what we'll be having here will now become nx. Sorry, n squared. That will then become what we have. Now then the last thing we're going to do is to say this is plus minus. And then close this up and put your limits 0 to 2 pi. Now what I've just done is actually very fast. What I've just done is actually very, very fast. But the thing is, since I'm explaining it for the first time, you're really going to think it's difficult. It's actually simple. Especially when you have something like an s squared here. When you have an x squared or you have s cubed, you're going to appreciate this very format. It's still the same thing as when you use the formula for integration by parts. So this will be 1 over 2 pi, and then let's just simplify this whole expression. This will be x sine nx over n, minus minus to give us plus. So this is cos nx over n squared. Then we put our 0 to 2 pi, our limit. Now at this point, anywhere we see x, we're going to put 2 pi. That's the upper limit. And anywhere we see x, we're going to put 0. That's the lower limit. But the good thing about this is, take note about these special values. Sine n pi is equal to 0. Yeah, sine n pi is equal to 0. So each time, take note, each time my limits are 0 to 2 pi. Each time my limit is 0 to 2 pi, and I have a sine, I must always put 0, because the answer will be 0. Sine 0, when I put in 0 here, sine 0 is 0. Sine 2 pi is also 0. So for these two limits that I have here, the value of this whole part will definitely be 0. So this guy is gone. This guy will definitely be 0. Also take note that sine of minus n pi is still 0. So anything that has to do with n pi, sine 0, they're all zeros. So it's a special what? It's a special angle. So that guy is gone. Now this next one, let us now put this in because we have to be sure about this. Even though I feel that's going to be 0 anyway. So this is 1 over 2 pi. And let's put in this. So we're going to have cos of 2. So this is cos 2n pi. Because anywhere I see x, I'm going to put 2 pi. So if 2 pi is here, n times 2 pi is 2n pi. Then divided by n squared minus, for the lower limit, this will be cosine of 0 over n squared. That's what we're going to have. Okay, so let's proceed. So this will be 1 over 2 pi. Cosine of 2n squared, 2n pi is 1. So this is 1 over n squared. Cosine of 0 is 1 over n squared. Another special value you need to know is for cosine. Cosine of 0 is 1. Cosine of 2n pi is 1. But cosine of n pi is minus 1 to the power of n. So that's it. But there was no n pi here. There's 2n pi. There's 2n pi. There's 2n pi. So if you cannot follow this, if you should put a 2 here, anyway you see n and you put the 2n. So let's say this n now, there's now a 2n pi. That means this minus 1, the n here will now become 2n. Now let's see. What is minus 1 raised to the power of 2? Minus 1 raised to the power of 2 is 1. Because minus 1 squared is plus 1. So when you do this, this will just be 1. That was why I just wrote 1 here. That's why I just wrote 1 here. Now see, 1 over n squared minus 1 over n squared, they are both the same, right? They're subtracting each other. So if these two are subtracting and you get 0, 1 over 2 pi times 0, that's just 0. So this guy is gone. This one is gone. So our a sub n is 0. I think let me just write my answers here. A naught is pi. Where's this guy? A sub n is 0. So let's find b sub n, our third coefficient. Okay. Remember to hit the subscribe button, like this video, and share it across to your classmates. So let's find b sub n. Now b sub n is 1 over pi integral from 0 to 2 pi f of x sine nx dx. This is what we have. Okay, so this will be 1 over pi integral from 0 to 2 pi. Our f of x is half of x. That's the, remember we've actually found what our function is. It's half of x sine nx dx. Okay, now half times 1 over 2 is 1 over 2 pi integral from 0 to 2 pi of x sine nx dx. Okay, and this is 1 over 2 pi. Now let's integrate this. We're going to use integration by parts, but I'm going to use a faster approach. So I'm going to write x down. So write x down. Now, differentiate x. What would you get? 1. Differentiate 1. What would you get? 0. But the 0 is not useful. So what I'm going to write is 0. Now, this is sine nx. So we're going to be integrating this one. So integrate this. Integrate sine. We're going to have minus cos. So open up a bracket. Minus cos nx over. Differentiate the nx. We're going to have n. So this is what we have. Okay. Now this very bracket here, integrate it again because this one, something should multiply it. So integrate this part again. Remember, this is a shorter approach to integration by parts. So you integrate this part again. What we're going to get is, there's a minus here, so I'm going to write that minus first. If you integrate cos, you're going to have sine. So this is sine nx. Then this nx differentiates nx, you're going to have n. Differentiates nx, you're going to have n. So the n will come and meet this n that has been here before. So that's n squared. And then put a plus and a minus. And the next thing you're going to do is to put in your limits, 0 to 2 pi. Okay, now let's simplify the bracket. So this is 1 over 2 pi. And then we have plus minus, this will be minus x cos nx over n. And then minus times minus, that's plus sine nx over n squared from 0 to 2 pi. Sorry. So this is 1 over 2 pi. So let's put in our limits. So this will be minus. Let me bring out this minus is a constant. Okay, just leave it there. There's a reason I don't want to do, but I can actually do that. But there's a reason I don't want to do that. So this is minus. Our value of s the first time will be 2 pi. So this will be 2 pi cos value of s again is 2 pi. So 2 pi times n is 2n pi divided by n. So this is the first bracket, upper limit. Minus, for the lower limit, we're going to say minus s for the lower limit is 0. So this will be 0 cos 0 over n. Now, if you notice, I did not put the sine nx. Do you know why? Because if I should this nx here, if I should put 2 pi, it will give me 0. Sine of n pi. So whatever the n is, even if the n is 2n pi, it will still be 0. Let me write it here. That sine 2n pi is also 0. So then sine 0 is still 0. So this part is just gone. It's gone. Okay, so let's see. Now this part is still 0, right? Because 0 times cos is still 0. So 0 times anything is 0. So this side is 0. So this is 1 over 2 pi times minus 2 pi. What is cos 2n pi? Cos 2n pi is 1 divided by what? N. Because this is the only bracket that will be remaining. So you write the minus, write the 2 pi. Cos 2n pi is 1. So when 2 pi cancels out 2 pi, what will be remaining? Become minus 1 over n. So this value, ladies and gentlemen, is your b sub n. So this is minus 1 over n. Now, and what does this tell us? This tells us that our graph, or our function rather, our function has no cosine embedded in it because our a sub n is 0. It has no cosine component in it, so it's 0. Because if you actually draw this graph continuously, and even draw the other side of the other part of it, this graph will never look like a cosine. That is why it has no cosine component. But for the sine component, it does have something that looks like the sine, and that is why there's a minus 1 over n. Now let's proceed. Remember that what we have just done is to only find the coefficients. So right now, let us find the Fourier series. How we represent this? So f of x is a naught over 2 plus the sum from n equal to 1 to infinity of an cos nx plus the sum from n equal to 1 to infinity of bn sine nx. Now we know that this one is 0. This guy is 0. So this will not be existent. So that's 0. Now what is our a naught? Our a naught is pi. So this will be pi over 2 plus the sum from n equal to 1 to infinity. What is b sub n? Minus 1 over n. Minus 1 over n sine nx. So if the expression says leave your answer, okay, let's bring out this minus first. You can bring out this minus. So this is pi over 2 minus the sum from n equal to 1 to infinity of 1 over n sine nx. If they say in terms of n, leave your answer, you're going to leave it like this. But if they say, okay, what is the Fourier series up to the 5th harmonic? Because you could be asked to represent it like that. So we've done harmonics before. So when n here is 5, that's the 5th harmonic. Because here's the thing. If I have the time, I'm going to represent all of this and impute the value into this video if there is time. So what you're going to do is, it's either, okay, just do this yourself. Download Desmos or GeoGebra. Download your graphing calculators and put this into the graphing calculator, and also put, where is half of x, yeah, and also put half of x. You will notice that this function is looking like half of x. Now, to make it much more better, because your calculator might not really have the strength to sum it from 1 to infinity, because infinity is a very large number. So it might not really have that variability, because you're not using a supercomputer, you're just using your phone. So you're not using a supercomputer. So it might take up time. I've noticed this sometimes when using Desmos. So when using Desmos, I will sum this up, and I'll be adding more harmonics, because the more harmonics you add up, the more your graph start fine-tuning to become this representation. So like I said, if there's time, I might just put it in. I might edit and put it in. So this is pi over 2 minus, now let's start. When n is equal to 1, this will be 1 over 1 sine 1x. So you could just say this is sine x, because 1x is the same thing as x. Then plus, it's a sum. So the next one, n will be 2. So this will be 1 over 2 sine 2x. Now the next one will be 3. So this will be 1 over 3. Anyway you see n, that's where you're going to be putting the number. 1 over 3 sine 3x. The next one is 4. 1 over 4 sine 4x. Next one is 5. 1 over 5 sine 5x. Just going to be adding it just like that. So like I said, when you use your graphing calculator, if you write it like this, you will see that the more terms you're adding, when you add 1 over 6 sine 6x, 1 over 7 sine 7x, you might not have the time to do that, but you start seeing that the graph will be looking like this, and that's your main aim. The graph will be looking like this. Also take note that in the graph, you can change your x-axis to be from 0 to 2 pi. You could actually do all of those. But remember, it might not be really useful for you if you don't really want to get the beauty of this concept. But it's fine. Now, if you want to do it, you can also do it from here. You could impute this into Desmos or GeoGebra. You could impute this. But when it comes to this infinity part, because there might be no symbol for this. So if you just type inft or /inft, you might have it. But like I said, when you put this in, your calculator might not really have the strength to compute it. So what you do is remove the inft and you put in 1, 2, that is a sum from n equal to 1 to 2, or sum from n equal to 1 to 5, just like that. The more you're increasing this number, the more your graph is looking like this. So that will be all for this video. Thank you very much for watching, and I'll see you in the next one. Bye.